What's up, everybody? In this video, we're going to be covering USACO's 2019 December contest at silver level. Problem number 1, MooBuzz. Farmer John's cows have recently become fans of playing a simple number game called FizzBuzz. The rules of the game are simple. Standing in a circle, the cows sequentially count upward from 1, each cow saying a single number when it's her turn. If a cow ever reaches a multiple of 3, however, she should say fizz instead of that number. If a cow reaches a multiple of 5, she should say buzz instead of that number. If the cow reaches a multiple of 15, she should say FizzBuzz instead of that number. A transcript of the first part of the game is therefore 1, 2, fizz, 4, buzz, fizz 7, 8, fizz, buzz 11, fizz 13, 14, FizzBuzz. This is actually a classic programming problem. I encountered this first time in high school, and then actually I think again in college. I've had a number of students that have to do this as a programming assignment. It's usually done in introductory to programming classes. Except there's going to be a twist on this one that makes it difficult. But this is actually also kind of fun to just play with friends. It's a lot more difficult than you would think, especially when you start trying to go quickly and get competitive. Having a slightly more limited vocabulary, the version of FizzBuzz played by the cows involves saying moo instead of fizz, buzz, and FizzBuzz. The beginning of the cow version of the game is therefore 1, 2, moo, 4, moo, moo, 7, 8, moo, moo, 11, moo, 13, 14, moo, 16. Given n, where n is 1 to 10 to the 9th, that's a big red flag. Please determine the nth number spoken in the game. So the challenge of this game, the challenge of this assignment isn't just to make something that prints out 1, 2, fizz, 4, buzz, fizz, like what you would see in an introductory to programming class. The challenge of this game is saying, for example, if I want the second number, that's this number. If I want the third number though, that's the 4. And the fourth number is the 7. And then the further challenge is I'm going up to 10 to the 9th, which means if I want the 10 to the 9th number, that's the billionth number. But remember, not all of these are numbers. About half of them are numbers, which would mean I would have to count through about 2 billion numbers, or 2 billion attempts until I get to the 1 billionth actual number. And that's going to go way over time complexity. So we cannot afford to brute force this. Scoring test cases 2 to 5 satisfy n less than or equal 10 to the 6. So you can get about half credit if you brute force, looks like. Input format is coming from the file called moobuzz.in. The input consists of a single integer n, and remember n means we want the nth number. The output format is to moobuzz.out, which is to print out the nth number spoken during the game. So for example, sample input is 4, sample output is 7. Fourth number spoken is 7. The first 4 numbers are 1, 2, 4, and 7 because 3 would be divisible by 3. 5 is divisible by 5. And 6 is divisible by 3. So none of those numbers get spoken. So what I would recommend doing is maybe write out a program that prints out the first, 50 of these numbers and kind of just look at them and see if you can figure out if there's some sort of a pattern we can exploit. Because ultimately, just because of the fact we know this time complexity is going to be 10 to the 9th, and we know that we can't do 10 to the 9th of anything, we know that this means there has to be some sort of a jump occurring. So take some time to think about that and maybe run this with pencil paper or write a program to print out the first 100 numbers or 1,500 numbers, something. And then we'll run through some strategies. All right, so the first thing I'm going to do is I'm going to write out the first 30 numbers. So I've got 1, 2, moo, 4, moo, moo, 7, 8, moo, moo, 11, moo, 13, 14, moo. That's the first 15. Let's go down the next 15. And this is maybe something you would have noticed if you tried to write these out already. 16, 17, 18 is divisible by 3, so moo. 19, 20 is divisible by 5, so that's a moo. 21 is divisible by 3, so that's a moo. 22, 23, 24 is divisible by 3. 25 is divisible by 5. 26, 27 is divisible by 3. 28 is divisible by nothing. 29 is divisible by nothing. And then 30 is divisible by both. So you might have noticed that every 15 of these we hit a cycle. On the first 15, when we moo, is the same time we moo on the next 15. This is the case all the way up. So one of the things you might be able to do to save some time is to keep in mind that every time we jump across 15 numbers, we say 8 numbers. So for example, if I wanted the 8th number is going to be, let me see, 1, 2, 3, 4, 5, 6, 7. The 8th number is 14. So let's actually circle these. 1, 2, 3, 4, 5, 6, 7, and then 8 is 14. The ninth number is going to be 16. 9, 10, 11, 12, 13, 14, 15, 16. So every set of 15 numbers, we are saying 8 numbers. So if I were to say, I want the 20th number, for example, then I know that 0 is the 0th number. I know that 16 is the 9th number. Actually, let's start from 1. I know 1 is the first number. I know 16 is the 9th number, so I'm going plus 15, and then plus 8. I know that if I go another plus 15, I would get to 31, because 16 plus 15 is 31. And if I go another plus 8, I would get to 17. So I want the 20th number. I'm up to 31 with 17. And from here, I can just simulate 32, 33, 34, 35, 36, 37, 38. Let's count this up. Okay, so 31 is the 17th number. 32 is going to be the 18th number. 33 is divisible by 3, so that's a moo. 34 is going to be the 19th number. 35 is divisible by 5, so that's a moo. 36 then would be the 20th number. So that's one strategy you can use, is adding 15s and adding 8s. But if you think about it, you can also just do that with algebra. So let's go back. We figured out, what was it, 36? I figured out 36 is the 20th number. Let's clear this. So I want the 20th number, which I mentioned I'm pretty sure is 36. So we want to get to the 20th number as fast as possible. We know that for every set of 15 actual numbers, we're going to dock off 8 of these n numbers. They're going to be 8 spoken numbers. Since I know I want the 20th number, if I were to do 20 divided by 8, I know that this is going to be in the third set. So it's going to be 2 remainder, what is that? 2 remainder 4, 16, yeah. So what that means is that the first set has numbers 1 through 8. The second set has numbers 2 through 16. The third set is going to have, 9 through 16. 9 through 16. And then third set would be 17 to 24. Since I want the 20th number, I know it's going to be in the third set. And I can find that by doing the division. When I divide 20 by 8, I get 2, which means I'm going to have to fully skip 2 sets. And then it's going to be the 4th number of the third set. So starting from 17, I can go 17, that's the 17th number. The 17th number is starting at 31, because that's going to be 15 times 2 plus the one that starts it. So 31 and 17. And then again, I can just simulate from there. 32, 33, 34, 35, 36. Checking if modulus 3 or modulus 5 is equal to 0. 32 modulus 3 is equal to 2. 32 modulus 5 is equal to 2. So that's going to be the 18th number. It's not divisible by either. 33 modulus 3 is 0, so that's going to be a moo. 34 modulus 3 and modulus 4 both are not 0, so that's going to be the 19th number. 35 is divisible by 5, so that's going to be a moo. 36 is not divisible by anything in terms of, 36 is divisible by 3. I messed that one up. 36 should have been a moo. Let me see. 31, 32, 33, 34, 35. Yeah, 36 should have been 37. My bad. 37. 37. And that's the 20th number. Okay, so then when we get into very large numbers, for example, if I want the 123rd number, or let's do 123,496th number. So 123,496th number, it's going to be too much, obviously, for us to do by pen and paper. But again, if we divide this by 8, divided by 8, we know that we will know how many blocks of 15 we have to have. So I'm just going to do this in a calculator real quick. 123,496 divided by 8. I got 15,437. 15,437. So 15,437 sets have to be skipped. So 15,437 sets with 15 numbers per set. We're going to multiply that. That's going to be 15,437 times 15. This is going to give me 231,555. 231,555. So if I skip this many sets, if I skip this many sets, 15,437, then I will be at number 231,555. So 231,555 is the 15,400. Yeah, let me look at that. 15,000. Yeah, 400. I'm running out of room here. 437. 15,437th number. And from there, then I can. Did that come out evenly? 15,437. I wanted the 123rd for. Wait, what happened with that math there? That's how many sets I skip, which means, yeah, I'm at 231,555 to get to, oh yeah, to get to 123,496. Okay, I'm running out of room here. Let me, 231,555 is the 123rd 496th number. I didn't have a remainder on that, did I? 123,496 modulus 8. Yeah, that divided evenly by coincidence. Okay, so let's make it the 97th number, just so they don't come out exactly even. If it was 97th number, then it would be 15,437 with a remainder of 1. Then I would start counting at 231,555, which is my starting point. And the way I got that is I got 123,497. I divided it and rounded down. I multiplied it then by 15. And then I know that this many numbers, I have to do a +1 on that because my first number is at 1. So that's going to be 6. This number right here is the 123rd 496th number. So if I want the 123rd 497th number, then I have to count up by 1, 231,557, and check to see if this is divisible by 3 or 5. 231,557 modulus 3 is 2, so it's not, which means this would be the 123rd 497th number. Then 231,558 would be a moo. And if you look at that, that actually still corresponds with this. This is 1, 2, and then 3 is a moo. So yeah, so then this would be, if I wanted the 123rd 497th number, it's this over here. If I want 123,498, it's going to be the next number, 231,559. So to recap, whatever number it is, if I want the 123rd 497th number or whatever it is, I first divide by 8 to figure out how many blocks I'm going to skip, because I've got 8 numbers, 8 spoken numbers per block. So if I want the 123rd 497th number, I would divide it by 8. That tells me how many blocks I'm going to have to go through in order to get to that n value. It comes up with this many blocks, 15,437, which I can multiply by 15. And then again, I'm pretty sure I have to add 1 to that because I start counting at 1. And then that is the first number. And then that's going to correspond to number 123,496, because I can find that by, that's my, actually that's the number of blocks times 8. So once we round down, we got our rounded down number. So I got 123,497. I divide and round down to 15,437, and I multiply by 8 to get my starting counter here. And actually, I think this also should start by counting by adding 1, 7. That would be 8, and that would be 9. You'll have to double check that when you write the code. I may be off by 1 there. I have to write the code to test it. But anyway, that's the procedure. Figure out how many blocks you need to skip by using division. Multiply by 15 to figure out what your number is going to be. Multiply again by 8 to figure out what number that corresponds to, and then just run through it in a while loop. And that should give you the answer. All righty, good luck coding it. I'll talk to you in the next one.